Space, the last great unknown. NASA's mission to unravel the mysteries of mankind's final frontier, to search for new knowledge and understanding,
Godspeed, John Glenn.
and to lead us towards a peaceful and unified future in space.
To the moon and the planets beyond.
The Eagle has landed.
This two-part film will explore 10 of NASA's greatest achievements in space and science and reveal how they are responsible for continually shaping the way we live our lives on Earth and how we view our place in the universe.
It's one small step for man, one giant leap for mankind.
Human beings can turn their attention to the most improbable and the most audacious of endeavors.
It was the essential first step to get an American into space, and it worked.
The International Space Station truly is a wonder of space engineering.
The Hubble Space Telescope is a unique instrument.
Pathfinder did suggest that Mars may have had life early on in its history.
With the right amount of money, the right amount of skill, and the right amount of public support, we can do anything and go anywhere.
For the eyes of the world,
Absolutely incredible.
now look into space,
Okay, here we go.
to the moon and to the planets beyond.
Lift off.
And we set sail on this new sea to solve these mysteries, to solve them for the good of all mankind.
Last time in part 1, we saw how Alan Shepard launched to become America's first astronaut.
Freedom 7 with astronaut Alan B. Shepard reports all systems go.
How NASA handled the triumphs and challenges of Ed White's Gemini spacewalk.
Beautiful job.
The legacy of the Pathfinder rover and its continued influence on the exploration of Mars. The planetary and deep space discoveries of the Voyager program. And how the Hubble Space Telescope has opened up the history book of our universe.
For the eyes of the world, now look into space.
Apollo 8 was NASA's first mission to attempt to fly humans to the moon and back, and arguably the boldest decision ever made in the history of human exploration. Facing serious speculation that the Soviet Union were preparing to send cosmonauts to the moon, NASA decided to reassign Apollo 8 to keep the US ahead of the Soviets in the space race. Instead of their planned Earth orbit mission, the three-man crew of Apollo 8 would now fly across the vast ocean of space, orbit the moon, and hopefully return safely to the Earth.
Apollo 8 was a very brave mission. They were going to go up to the moon and round the moon, which means for the first time, humans were going to go outside the area of influence of the Earth. You know, not on the Earth, not orbiting the Earth, they were going to go and orbit the moon.
Apollo 8 was the most audacious human spaceflight mission in history. This mission was going to go hundreds of times further in distance than what had been achieved until then in low Earth orbit.
Although they had tested out all of the hardware and the systems in Earth orbit, they had never left Earth orbit with humans. So it was a big risk.
It really was starting human exploration of deep space.
With its new circumlunar objective, not only could Apollo 8 keep the US ahead in the space race, but meet some significant technical milestones for NASA.
The importance of Apollo 8 for the program was that we needed to demonstrate that we could operate the Apollo spacecraft in an environment that no manned spacecraft had ever worked before, between Earth and Moon, where there was continuous sunlight 24 hours a day, and that the thermal control and that the communications at those great distances could operate in this completely new environment, and that the rocket motors could fire it into and out of lunar orbit. Essential for a landing.
As a mission of many firsts, the Apollo 8 crew would also be the first human beings to ride the mighty Saturn V rocket, the most powerful machine ever built by man.
It was the first time that a human crew had ridden a Saturn V rocket. NASA took this audacious risk of not only putting a human crew on board, but also sending them on a mission way beyond high Earth orbit, only a few thousand miles away. This mission was going to go 250,000 miles.
NASA's updated schedule left Apollo 8 astronauts Frank Borman, Jim Lovell, and Bill Anders preparing for a new mission that would launch almost 3 months earlier than planned. But by December 1968, Apollo 8 was ready to make history.
This was a real leap in many, many ways. And with Borman, Lovell, and Anders, they had a phenomenal team. They really captured the imagination.
We now have a report that the liquid hydrogen tank on the third stage is pressurized at this time as we come up on the 60-second mark on a flight to the moon. The vehicle now is completely pressurized. 45 seconds, final reports coming from Frank Borman aboard the spacecraft. T-minus 15, 14, 13, 12, 11, 10, 9. We have ignition sequence start. The engines are armed. 4, 3, 2, 1. We have liftoff.
Liftoff. The clock is running.
That's clear. Clock starts, right? Roger, clock. The tower is clear. Apollo 8, you're looking good.
Roger.
The weight of a warship lifting into the air.
It was just an enormous machine. It was a phenomenal thing to watch.
Apollo 8, Houston, your trajectory and guidance are go, over.
Thank you, Michael.
Yeah, you're looking real good, Mike. Apollo 8, Houston, you are go for staging, over.
Thank you, Houston. Apollo 8. Staging. The first stage was very smooth, and this one is smoother.
Apollo 8, you are go for TLI, over. We're go for TLI.
Here we were, leaving Earth and breaking that bond with our home planet to place men within the gravitational grip of another world in space. It was awesome.
During Apollo 8's flight to the moon, astronauts Borman, Lovell, and Anders became the first humans to venture beyond low Earth orbit. After 3 days and flying 380,000 kilometers, Apollo 8 arrived at the moon and entered lunar orbit.
This is Apollo Control, Houston. There's a cheer in this room. We've got it. We've got it. Apollo 8 now in lunar orbit.
Apollo 8, Houston, what does the old moon look like from 60 miles, over?
The moon is essentially gray. No color. We can see quite a bit of detail. The craters are all rounded off. There's quite a few of them.
Roger, understand.
One of Apollo 8's main objectives was the reconnaissance of NASA's planned landing sites. And over the next 20 hours, the crew collected 700 photographs of the lunar surface in never-before-seen detail. On their 9th orbit of the moon, the crew sent a Christmas Eve message back to Earth, which was watched by the largest global television audience in history.
For all the people back on Earth, the crew of Apollo 8 has a message that we would like to send to you. In the beginning, God created the heaven and the earth. And the earth was without form and void, and darkness was upon the face of the deep. And God said, "Let there be light." And there was light.
This really was magic. Those words have a raw power. Genesis, as a passage from the Old Testament, is at the core of 3 of the world's great religions. And so this resonated not just with people in the United States, but with a global audience.
This was no longer a nation fulfilling its national aspirations, but it was a world collectively represented by 3 humans traveling in orbit around another world and invoking a spiritual sense of identity that rose above the petty bickering. It made people realize there was something bigger, grander, and even more meaningful to the human spirit.
And from the crew of Apollo 8, we close with good night, good luck, a Merry Christmas, and God bless all of you on the good earth.
However, the most famous image captured by Apollo 8 was not of the moon, but of the Earth. Known as Earthrise, this photograph was taken by astronaut Bill Anders and is believed to be the most reproduced image in human history.
The power of that image gave humans on Earth a perspective of just how unique in our solar system our planet is. All of life that we know thus far has emerged on that pale blue dot, that sphere that's there. And to imagine that 3 human beings can look back at where they came from and cover it up with their thumbs, it still makes the hair on the back of my neck stand on end thinking about it.
And these things, I think, are tremendously important to give everybody a view of our place in space, because that's our world. Look how thin the atmosphere is, look how fragile it looks, look at all this space around, and it's tiny. Look after it.
The pictures of Earth from space mobilized an environmental movement in the United States. That we have an Earth that's very fragile. If we continue to rampage through its resources, consuming them at a prodigious and profligate rate, that we will soon have a dry and dusty bowl such as that we see in the world we went to visit, the moon, and saw an Earth that was so different, so beautiful, so full of life, but so fragile.
Apollo 8's successful first flight to the moon paved the way for the lunar landings that followed and allowed NASA to meet President Kennedy's goal of placing a man on the moon by the end of the 1960s. But perhaps Apollo 8's greatest legacy was that in our quest to study the moon, humanity truly discovered the Earth. And only by leaving our planet behind could we look back and see for the first time our whole world. NASA's space shuttle represented the first vehicle in a new breed of spacecraft, based off a radically new approach to space travel. The plan to replace the costly method of launching manned capsules on expendable rocket boosters with a reusable spacecraft. Not only would such a vehicle reduce the cost of space exploration, increasing America's access to Earth orbit, but it could also support NASA's ambitious future of permanently manned space stations.
The shuttle was conceived as a reusable launch vehicle when it was obvious that throwing these rockets away after only one use was going to be unsustainable if the flight rates went up and up and up. It would bankrupt the space program.
The cost of getting to space has always been very expensive, and the idea was to build something that you could bring back, whether it was with cargo or whether it was astronauts. And that ought to reduce the price to orbit per kilogram by a factor of 10.
Long before the first landing on the moon, people were looking to the future and realizing that if we had space stations, we'd need to routinely go back and forth on a regular basis. And so we needed some kind of vehicle that was reusable. And then people became aware that, well, if you've got a vehicle that can do that, it can maybe launch small satellites. And then when it became apparent that maybe we wanted to build a space station incrementally through separate modules assembled on a pay-as-you-go basis, rather than one giant space station launched on a super booster, you could do that with shuttle.
The design of the space shuttle resembled that of a conventional aircraft, with 2 wings and a tail. In this configuration, the shuttle was more like a space plane that could glide back to Earth, land on a runway, and be readied for its next mission. A unique feature of the shuttle design was its large cargo bay that would allow the vehicle to ferry a wide variety of scientific payloads into orbit. This would enable NASA to easily deploy satellites and, for the first time, capture and return payloads back to Earth.
The shuttle was really meant to be a multifaceted tool. It was a logical thing to do, a logical step. In particular, you're looking for a tool that you could use to mend spacecraft, a tool that you could use to service an international space station, for example, or any space station. You could launch things from it. Myself personally, I was involved with a thing called the Solar Maximum mission, which was the first in-orbit repair of a spacecraft. You couldn't have done that any other way, sensibly. You had a machine that could get up there, literally grab the spacecraft, pull it into the cargo bay, people could work on it, and you could relaunch it. And it's done all of those things over the years and done them brilliantly.
After nearly a decade of development and testing, NASA's Space Shuttle fleet finally went into service in April 1981 and launched a new era of manned exploration.
Firing chain is armed. Go for main engine start.
OTCTLT, APU pre-start complete, 3 great talkbacks. Thank you, Charlie.
STD, CCLS 1212, we're ready to go. Copy that. On my mark. 3, 2, 1, mark.
Two, 1, 0, and lift off. The shoulders of the space shuttle, America will continue the dream.
The space shuttle spreads its wings for this journey into history.
Roll program.
Roger, roll, Discovery.
Roll program complete. 4.5 million pounds of hardware and humans. Heads down, wings level on the proper alignment for its 8.5-minute ride to orbit.
Go with throttle up.
Roger, go throttle up.
The space shuttle's traveling almost 2,600 miles an hour, 21 miles in altitude, 24 miles downrange. Standing by for solid rocket booster separation. Good solid rocket booster separation, the main engine steering the shuttle on a pinpoint path to its preliminary orbit.
Between 1981 and 2011, NASA's fleet of 5 space shuttles flew a total of 135 missions. During their 30 years of service, the shuttles carried more than 350 astronauts to and from orbit, and allowed mankind to push the boundaries of humanity's space exploration. The shuttles launched and repaired hundreds of satellites, acted as orbital space laboratories, and assisted in the construction of the International Space Station, the largest and most complex object ever assembled in space.
The shuttle's main objective was, of course, as a routine ferry back and forth between the surface of the Earth and near space. But clearly, no other vehicle at the time on the drawing board or conceived could possibly have assembled the 400-ton International Space Station that has been permanently manned since the year 2000 and may very well have at least 3 decades of life for scientists from all over the world.
Despite NASA's supreme efforts, the shuttle program did not make space travel as frequent or affordable as predicted. Originally billed as a vehicle that would launch twice a month, in reality, shuttle missions averaged at 4 a year. And the operational costs of the program were higher than anticipated, due to the extensive maintenance required to keep a reusable spacecraft in service. The safety of the vehicle was also questioned, following the tragic accidents that led to the loss of Space Shuttles Challenger and Columbia and their respective crews. But inquiries into both incidents revealed that management problems at NASA were to blame, rather than flight engineer complacency or the reliability of the shuttle hardware, concluding that tragically, both disasters could have been avoided. Sometimes the failings of the shuttle are made to overshadow its achievements, but make no mistake, this experimental spaceplane has set a staggering benchmark for the future of reusable spacecraft.
Reusable space launch vehicles are essential for the future if we're going to cut the cost of space travel and space transportation. They're very costly to develop, very difficult to produce, but they are the only way to get low-cost transportation back and forth between Earth and space. They are inevitable.
I think the lasting legacy for Shuttle is that it is possible to both bring the vehicle back and astronauts back in the same vehicle that they went up on, and that there is at least now the practical possibility of reducing cost to orbit, but there's still a long way to go yet.
We cannot continue to use rockets that we throw away after each launch. The ordinary jobs and the routine access for humans and for medium to small cargoes has to go on reusable launch vehicles. There's no other way.
What started as a truly space-age concept evolved into an iconic vehicle like no other machine ever built. The Space Shuttle was a gateway to Earth orbit that for millions around the world came to symbolize the adventure and spirit of exploration.
The first launch that I ever saw live on TV was a Space Shuttle launch. I found that inspiring. As a small child, you see a plane being launched into space. And certainly that was inspirational from my perspective.
You have to sort of stand to one side and not ignore the fact that a huge amount has been achieved by this general purpose tool that has allowed us to do a huge amount that a lot of us have benefited from in terms of the machinery we can get up there, machinery we can maintain. Even if it's from people understanding the universe, because I can see the images from Hubble that was launched with the shuttle and managed through shuttle missions. Just bringing people together that can only be good for mankind. The shuttle played a huge part in that, and we should never forget it.
Finally retired in 2011, NASA's Space Shuttle fleet not only paved the way for the vital next step in manned spaceflight, but has enabled the technological world we now enjoy, and should be forever heralded as one of NASA's greatest achievements.
The end of a historic journey, and to the ship that has led the way time and time again, we say farewell, Discovery.
The International Space Station is a habitable space laboratory parked in low Earth orbit and the greatest international collaboration in the history of human space exploration. Home to a multinational crew of 6 astronauts who live and work in space, the ISS was built to advance our long-duration spaceflight capability. But despite being the blueprint for global space cooperation, the International Space Station has its origins deep in the Cold War.
Back in the 1980s, relations between the Soviet Union and the United States were still pretty much in a deep freeze. Now, NASA had plans for its own space station, Freedom, but the budgets were ballooning. And NASA realized that its aspirations for having a long-duration capability for spaceflight were going to be pretty much on the shelf for as long as the shuttle program was going on. At the same time, the Soviet Union had spectacularly built up human spaceflight experience through the series of Salyut space stations culminating in the Mir program. NASA had done nothing like this since Skylab in the early 1970s.
Although the Skylab program had been a resounding success for NASA, the agency was in desperate need of space station freedom to advance its orbital operations. But when the Soviet Union collapsed at the beginning of the 1990s, it gave NASA a golden opportunity to support and collaborate with the new Russian space agency. And in 1993, plans for space station freedom were merged with Russia's proposed Mir 2 project to form the first international space station program. A global partnership of 15 nations worked together, despite differences in language, politics and manufacturing styles, to plan and complete the greatest engineering project in history.
The International Space Station truly is a wonder of space engineering when it comes down to human spaceflight. And the first components were launched in 1998. It's taken the combined resources of more than 15 nations and 40 missions to assemble this structure in Earth orbit that's larger than a football field. It's got a mass of nearly 500 tons.
You should think of the space station as a gigantic Lego set where bits and pieces are launched into space and then bolted together actually in orbit. It's far too big to be launched from the ground, and we actually don't have a launch vehicle that's physically capable of taking that whole structure into space on its own. So you have to launch it in pieces and assemble it in orbit.
The modular design of the International Space Station has allowed different bays and components to be engineered and manufactured by 5 different space agencies around the world. This unprecedented technological and political partnership sees Russian, Japanese, European and Canadian space agencies working alongside NASA to operate and service the ISS.
The international nature of the space station is probably the greatest success as a program rather than an individual mission or event that NASA has ever achieved, to bring together the nations of the world to what is now the full International Space Station, populated with former Cold War adversaries coming together to do science.
Since the arrival of the first crew in November 2000, the station has been constantly occupied by astronauts and cosmonauts from 15 different nations, representing the longest continuous human presence in space. The International Space Station is a unique scientific platform where research into biology, physics and astronomy converges with technological developments and innovation. In this orbiting laboratory, crew members conduct advanced experiments that would not be possible on Earth, with the unified goal of sharing breakthroughs and knowledge for the betterment of humanity.
The ISS truly is humanity's orbital space science outpost. The research that's being done on board is giving us new insights into so many different areas, from materials science to fundamental physics, because some of the insights gained from instruments on the station are giving us new ideas about the structure and possible future fate of the universe.
Vaccine development, orbital images assisting disaster relief, and educational programs inspiring future scientists, engineers and astronauts are just some of the medical, economic and environmental benefits the ISS is contributing to human life on Earth. In 2005, the station's sophisticated facilities were opened up to institutes and scientists on Earth. And now people all over the world are using this space research for Earth-based applications. But with all eyes on mankind's next giant leap in space exploration, the station is also paving the way for future missions to the Moon, Mars, and beyond.
A manned mission to Mars is going to be a very difficult thing to do. Although we have the basic technology, It's going to take at least 7 or 8 months to send people to Mars. Then they have to stay there for about a year before they can come back, which is another 7 or 8 months. So we're really talking about a round trip that lasts more than 2 years. The difficult logistic point is to work out how to survive for that length of time. Not just from a physical point of view, but actually if you're going on a long journey, you might have to learn how to grow food. And one of the things that the space station is a good platform for is learning how to grow things in low gravity conditions.
What we have learned is how multiple agencies from different parts of the world can collaborate even when there are political differences. And if we are to go to Mars, in my mind, it's almost guaranteed to be an international mission. So for me, ISS has been the challenges of human spaceflight engineering, building those huge structures and maintaining them when the politics on the ground might not be so rosy.
The International Space Station is the largest and most complex object ever assembled in space. A project which, after a decade of success, has proven its worth as an off-world science lab and pioneered techniques for building and maintaining equipment in orbit. But perhaps the station's greatest accomplishment is its blueprint. A blueprint that gives our world a chance to achieve goals together that single nations alone could not accomplish.
The legacy of what was achieved in the International Space Station is that despite political difficulties, despite uncertainties between partners of the International Space Station, that continues to be a committed preserve where we all get on with each other and work for the common scientific interests.
The ISS program from the start was politically driven, but what's emerged from it has been a fantastic tribute to cooperation between so many space agencies around the world.
You cannot now put the genie back in the bottle. A precedent has been set. This is the way forward, and it's a great way for settling political difficulties. Sleeves rolled up, working together.
Just 2 decades since the end of the Cold War, the International Space Station embodies what global cooperation can achieve. The ISS is humanity's first firm foothold for life in space. Our springboard for visiting destinations beyond Earth orbit. And another giant leap in mankind's quest to explore the final frontier. The Apollo lunar space program is cemented in time for the scale of its ambition and accomplishments. But one of the greatest moments in NASA's history was so nearly its worst. In April 1970, the Apollo program was in full swing. The last 16 months had seen 12 men fly to the moon and 4 walk upon its surface. And astronauts Fred Hayes and Jack Swigert were training alongside Apollo 13 commander and veteran astronaut Jim Lovell for NASA's most ambitious mission yet.
Apollo 13 really went to take a step further than the previous 2 Apollos that had been on the moon. They had landed in areas called mare, these sort of flat plains, so you only looked at the rocks that were right on the surface. And there's a lot of interest in what's happening down below the surface of those mare. So Apollo 13's aim was to go to an impact crater where some huge collision had happened with an asteroid. That impact had thrown material out, and it dug it up from lower regions of the crust. And Apollo 13 was targeted to try and get to rocks that were characteristic of a different age of the moon compared to Apollo 12.
Apollo 13 launched to explore the moon and follow in the successful lunar footprints of Apollos 11 and 12. But just 56 hours into the mission, the spacecraft suffered a devastating malfunction.
Apollo 13, Houston, we'd like you to stir up your cryo tanks.
Okay, stand by.
about 56 hours, all three of us heard a rather large bang, just one bang.
Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Stand by, they got a problem. We got more than a problem.
Okay, listen, you guys. Fuel cells 1 and 3 are offline.
All right, that's what we're reading.
When an onboard oxygen tank ruptured, 2 of the spacecraft's 3 fuel cells began bleeding precious power.
We gotta get a pressure readout on that thing.
O2 quantity number 2 is 0.
That's the end right there.
I can't believe that.
The mood in mission control was immediately one of disbelief.
I have absolutely no clue to what happened. Something happened to the fuel cells in the oxygen tank.
And when I looked up and saw both oxygen pressures, one absolutely 0 and the other one going down, it dawned on me, and I'm sure Jack and Fred about the same time, that we were indeed in serious trouble.
It looks to me that we are venting something out into space. It's a gas of some sort.
Roger, we copy your venting.
Not only is oxygen vital to keep the crew alive, but the spacecraft's 3 fuel cells could not generate power without it.
It was quite apparent to me that it was just a question of time that the command module was going to be dead.
We're still 70 to 80 hours away from the Earth.
Without power, the spacecraft would shut down, communication systems would die, and the crew would be stranded in space.
Within 2 hours, the 3rd fuel cell had to be shut down. That's the only means of electrical power for everything needed to get the crew back to Earth alive.
200,000 miles from Earth and trapped in a dying spacecraft, the crew of Apollo 13 faced a life and death crisis. NASA had just one chance to bring their men safely home.
We knew that the command module was going to lose power. The only way to survive the situation was to transfer to the lunar module, and we started going through procedures to get power on.
The initial reaction was stabilization, to get the whole mission stable so that we could at least buy a bit of time. Assign people to study how we keep the crew alive and how we keep our options open.
With its own independent life support, power and communication systems, the lunar module could act as a lifeboat. But with only a 45-hour lifespan intended for a 2-man crew, NASA ground teams had to work around the clock to keep 3 men alive for the 90-hour flight back to Earth.
The main difficulty that the astronauts had is they were losing power all the time, and they had to find a way of maintaining power for the whole duration of the flight.
To support 3 men for 3.5 days, the whole way in which it was operated had to change.
To combat the astronauts' dwindling consumables, NASA instructed the crew to power down the lunar module, preserving the spacecraft's limited water and electricity supply. However, the crew suffered serious dehydration, and the temperature inside the lunar module plummeted.
It was sort of a chilling coldness. The walls were perspiring, the windows were completely wet, and it wasn't too healthy. I recall that it was like reaching into the freezer for the food.
There was ice forming on the inside of the windows. The crew were beginning to suffer under those appalling conditions. It was a dire state. It was a real emergency situation.
The survival of the crew was further jeopardized by the looming problem of carbon dioxide buildup on board the spacecraft.
When you breathe oxygen, you exhale carbon dioxide. And that carbon dioxide, if you don't do anything about it, builds up in the sealed environment of the space capsule and becomes a poison.
Lithium hydroxide canisters were used to scrub the air supply of carbon dioxide. But with the commander module powered down, the lunar module's scrubbing system was being overworked, only designed to support 2 men for 2 days, not 3 men for 4 days.
It wasn't possible to take the lithium hydroxide crystals from the command module and place them in the lunar module because the shapes were different.
The command module canisters were square cross-section, and believe it or not, the ones in the LEM were round cross-section. This was a very serious problem. I mean, it could easily have been the end of the rescue mission had they not solved it.
NASA had just hours to engineer a system that patched the square canisters into the lunar module life support system, using only what the astronauts had available to them.
So we're talking about duct tape, plastic bags, pairs of scissors. And what had to happen in mission control is a complete set of flight instructions had to be devised for the crew so that operating in almost 0 centigrade conditions in a spacecraft deprived of virtually all of its electrical power, the crew had to build this material knowing that if they didn't get it right, they were going to be dead before their return to Earth.
The ground read us up a procedure in order to adapt some of the canisters, and as they read this thing up, Jim and I constructed one of these things.
Cut a piece of tape this long, put it up there, do this, do that. It worked a treat, you know. Within an hour of switching it on, the carbon dioxide levels were way down, and they were through that really serious consumable problem.
There were moments when I didn't know how much consumables we had, whether we could make it back or not, but in a situation like that, there's only one thing you can do. You just keep going, and you just keep thinking up where you can get more consumables. And so that's exactly what we did.
It is without question that one of NASA's greatest triumphs during the Apollo 13 rescue was the way Mission Control successfully stretched out the dwindling life support consumables. Had these consumables not been monitored and economized as accurately, the mission and the crew would have been lost.
In the entire history of human spaceflight dating back to 1961, Apollo 13 was the most dangerous episode in which the crew has successfully survived.
And there's one whole side of that spaceship missing. The whole panel is blown out from the base to the engine. Copy that.
What happened in Mission Control and by the crew themselves showed that the NASA spirit at the time was absolutely up to the challenge, not only of getting human beings to the moon, but returning them to Earth safely when you've got multiple emergencies coming up that are threatening your crew's survival again and again and again.
Extremely loud applause as Apollo 13 comes through loud and clear on the television display here.
I regard Apollo 13 as an immensely impressive example of engineering. The systems engineering, the organizational engineering was so solid, was so intelligent, was so well structured that when the accident happened, the organization was found totally capable of dealing with it. And I can't imagine why anybody would want to be anything other than an engineer.
Failure is not an option. And it was that idea that we could prevail. It was the finest example of that spirit that's not only in NASA, it's within people, this is humans that did this. In this situation, and all similar situations, it's really about people and about what they give beyond what they're asked for.
One of the most important points that can be made of this flight is the initiative that people have when suddenly faced with an unusual situation. I think it's amazing the way that people can respond so fast to get this job done.
The safe return of the Apollo 13 crew is a testament to the caliber and dedication of the engineers and astronauts of the Apollo lunar program, and is universally regarded as NASA's finest hour.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth. No single space project in this period will be more impressive to mankind or more important for the long-range exploration of space, and none will be so difficult or expensive to accomplish.
On the 25th of May, 1961, President John F. Kennedy challenged the United States to put a man on the moon by the end of the decade.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
NASA had just 8 years to pioneer the technology to shoot men into deep space and return them safely to the Earth. But in 1961, a rocket powerful enough to reach the moon did not yet exist. A landing vehicle capable of touching down on the lunar surface had not yet been designed. Spacesuit technology was in its infancy, and it was not even known whether humans could survive in the vacuum of space. In 1961, walking on the moon was science fiction, but by 1970, it had to be science fact. What followed was one of the most intense and unified national efforts the world has ever known, and the greatest engineering challenge in the history of mankind. In July 1969, Apollo 11 made history as Neil Armstrong and Buzz Aldrin became the first of 12 astronauts to walk on the moon.
Tranquility Base here. The Eagle has landed.
We copy you down, Eagle. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
I'm at the foot of the ladder. That's one small step for man, one giant leap for mankind.
The 6 Apollo lunar landing missions demonstrated the most audacious attempt to challenge humans on the technological frontiers of the 20th century that could ever have been put before a single group of people. Human beings can turn their attention to the most improbable and the most audacious of endeavors.
It felt like we were at the beginning of a human adventure, which made it terribly exciting.
For a magical moment, humanity was united as one. People were saying, "You did it for us." It wasn't seen that the United States had set foot on the moon. It was the human race. And so for me, that's the magic of Apollo 11 and all of those subsequent missions.
After the triumph of Apollo 11, NASA landed 5 more exploration missions on the surface of the moon, each more advanced and ambitious than the last.
Of the 6 Apollo lunar landing missions, the last 3 were incredibly productive scientifically because they built on the previous flights in a very big way. They had a lunar module that could stay 3 full working days on the surface, that had a lunar roving vehicle that could carry the crew miles to different sites of geological and scientific interest. It carried a much larger suite of experiments to operate for nearly 10 years after the crew returned, sending information back to scientists all over the world. That prodigious outpouring of data was really one of the greatest achievements of the whole Apollo program and transformed it from a political objective in getting to the surface ahead of the Russians into a very, very major scientific endeavor.
This unprecedented scientific yield has unlocked the history and evolution of our planet and the solar system. But the benefits of NASA's Apollo program are far more wide-reaching for us all.
Sending human beings to the moon laid the groundwork for exploration of the rest of our solar system, so sending robotic explorers off to Mars, Venus, but they also laid the way for international collaboration. Sending people up to the International Space Station, working together for a common cause would not have been possible without the technology developed through the Apollo missions. Hopefully, although it's NASA's greatest achievement to date, there's going to be plenty more equally exciting achievements down the line for exploring the solar system.
Between 1968 and 1972, 24 men flew to the moon and 12 walked upon its surface for the benefit of all mankind. The flags and footprints left behind during the Apollo lunar program have come to symbolize not only NASA's greatest achievement, but the achievement of an entire generation and the promise of mankind's future in space.
It's the world taking the next steps. It's not just NASA, and NASA's been fantastic and led the way, but all these voyages in space, we're all doing this together.
With the right amount of money, the right amount of skill, and the right amount of political and public support, we can do anything and go anywhere. And I think if we want to go to Mars, we can do that.
This renewed human commitment to deep space exploration that we're seeing, it's going to remind us of what exploration is all about. And once again, of what being humans is all about.
The space program is really responsible for telling us who we are. It's shown us our place in the universe and really marks the beginning of the environmental movement.
We didn't have respect for this planet until we could look back at it and see how unique it actually is. And if we don't look after it, our children's children will not be here to appreciate it in the way we can today.
Whatever the future may hold for space exploration, it's clear that what NASA has achieved in just a few decades has defined how we live on our home planet and how we will explore our future in space.
I personally like to think the greatest achievement of NASA is that it is a civilian-based agency, actually international in its aspirations to draw in a world community of scientists and researchers, and to inspire the next generation of students, scientists and engineers to literally go where no one else has gone before and be the representational catalyst for all spacefaring nations to follow it to the exploration of the solar system and beyond.
Many years ago, the great British explorer George Mallory, who was to die on Mount Everest, was asked why did he want to climb it. He said, because it is there. Well, space is there, and we're going to climb it. And the moon and the planets are there, and new hopes for knowledge and peace are there. And therefore, as we set sail, we ask God's blessing on the most hazardous and dangerous and greatest adventure on which man has ever embarked.